So in our DCC lab today, that is data center computing, we had a nice question. The question was, so given an array of like reals basically, usually you would assume that it's an increasing sequence, but what what sometimes happens is that you get inversions. That is, if this was like the increasing thing, like this was how the trend actually should be, but instead of that, in these two only you have a decrease or something like that. Now it's not like in these two only, you could also have a decrease like this. So maybe like this thing is actually bigger than all of these, or something like that, right? Or maybe like there's some section over here which this thing is bigger than, right? There's another inversion happening somewhere over here, I don't know. So like given a random list of numbers, you have to figure out how many inversions are there, which, okay, if I state formally, is basically you have to figure out all indices going from 0 to n minus 1, where n is the length of the list, such that I less than j, so I and j are indices, and let's say the list is a, so a sub I is bigger than a sub j. You have to figure out all of such ij pairs, right? So all ij such that this happens, and ij are under the usual constraints, right? Bigger than or equal to 0, less than or equal to n minus 1, integers. Yeah, so go ahead, give it a try. Okay, I'm assuming you have given it a try. So it's weird, but like the way you do this is the same as merge sort. So let me explain. We can do this recursively. First, what I'm thinking of is just two sequences which are increasing. So we know for sure these are increasing, or you could say non-decreasing. That's a better description. So these are two non-decreasing sequences, and let's assume. So this is weird, but we'll start off with an incorrect assumption. We'll start off with the assumption. I mean, that's done a lot in math, but I don't think this is like done in programming. Is it? I don't know. So we'll assume that, okay, let's actually color them. So this is like yellow, and this one will be red or something, I don't know. And let's for now say that these are like, I don't know, containing 4 elements, which I'm drawing as blocks. Okay, so say these are our two arrays, and let's assume that all the elements over here are actually bigger than all the elements over here. That is, these two combined, this array would actually be increasing. Okay, yeah, and now let's try to merge these two increasing arrays. So I already said that these are in fact increasing. So as you go to the right in this array, your numbers increase, and in this array as well your numbers increase. But then there's a certain break over here. So like, I don't know, this would be 1, this would be 59, and suddenly now this thing is 1 again, or 2 again, or something like that, right? Okay, so when we will merge these two, what will happen is that you will maintain 2 pointers. So the usual way of merging is, okay, actually let's just draw the pointers over here, in fact. So you have pointers, which I'll say is 1 and 2. So I'm marking them as 1 and 2. Okay, and then these pointers are going to move. So we'll actually make a bigger array first, with number of elements being the sum of these two, right? So this will now be 1 2 3 4 5 6 7 8. I'll put it here. This was bad. So 8, like that, right? So you'll make a bigger array, and then you will start putting these in here, right? The usual merge sort. So every comparison that you make, this, if it goes down, then yeah, that's okay, that's what we think should be happening. But if this goes down, then there's some problem. So okay, let's, I don't know, just take an example. Let's say that the first 3 elements are just from here, so this happens, and then the next one is from here. So what actually happened is that this one went down there, or you could say that this one was inserted between these, because we know that this one is going to lie somewhere in this range. So you could think of it as, inserting one of these blocks inside of this yellow array. So inserting that inside and then like enlarging it. I guess that makes sense. So let's say that you already know how many inversions there were like while forming this yellow array, and you already know the number of inversions while forming this red array. So not in the yellow array or in the red array, while forming these arrays, right? So it's a recursive process. That's why I'm saying you already know that. That's what we do. So now the task is to count the number of inversions in this array, right? Which is basically just those two numbers added up plus the number of inversions between these arrays. Now, what do I mean by that? I mean that when you compare elements, what you should do is that you should only take the left element from this array and right element from this array. And of course, all of these elements are considered to be on the right of this array. Here I'm using right and left instead of indexes because these are not actually joined yet. Okay. So since what we did is like basically took this out and then inserted it here, what we are also saying is that this thing is bigger than this one element, right? So for this block, okay, not for this block, actually it should be this block, right? That's the one I'm talking about. So for this block, so we inserted that here. So for this block, you have one of these elements from the yellow array which is less than it, and we were with the assumption that every which is bigger than it. That's what I should say, because this is gonna lie somewhere over there in this white unshaded part. We were with the assumption that this would be less than it, but now it's bigger than that. So like, okay, let's say that it's not 3 of these, instead if it's like 2. So I don't know, I'm just gonna color this. So like maybe it's something like this. This is what your array would be. I don't know, just taking one example. Oh well, this should be one less, I guess. So maybe if this was your array, what happened is that this block, which you were assuming to be on like the right side, the right half, is now suddenly over here. It is larger, it's smaller, yeah, it's smaller than 2 of these yellow blocks. So number of inversions between these two arrays involving this red block, that's just 2, because there are 2 yellow blocks which are larger than this red block, and we know that should not have happened. So the number of should not have happened is 2 for this red block. So just do 2, then plus, then you go for the next block. Wherever the next block is, you see the number of yellow blocks larger than that. In this case there would be 0 and then 0 and then 0, so this will just turn out to be 2. We know that's not the case all the time, so make a program for this. What you would do is, while comparing these two, you know what index you are going to be inserting this on, right? So let's just say that's a pointer 3. Okay, so we have not yet inserted this. We are yet to insert it. So this is our pointer 3, and you are inserting pointer 2 in pointer. Yeah, that's how it should be. So you're inserting this element over here, right? Yeah. Then that basically also says that 2 elements over here are going to be bigger than that red element. How do you figure out this number 2? Well, you just subtract from 4 the number of elements that are less than the number of yellow blocks that are already in the list 3, right? So that will be in pointer 1. So these are of course moving pointers, and when you will be inserting this, so this is the one that you are inserting. Pointer 1, that's gonna point to the next block that you could be inserting. So already these two have been inserted, so you are now pointing to this block. So pointer 1 is pointing to this block. So from this block onwards, all of the blocks will lie to the right of this block, right? So those are just 2 of these. Now of course pointers actually start off at 0, so this would be 0 1 2. So actually pointer 1 is going to be 2. So you just take the length of this, subtract from the pointer itself, instead of, yeah, so like if pointers were starting from natural numbers, if this was like 1 2 3, then you would do pointer minus 1 and then subtract that from n is 4 in this case. So you would do something like 4 minus 3 minus 1. In this particular case, that's not required. You just do 4 minus 2. That makes sense, right? So I'm not writing any variables over here because I don't want to give away the answer, like the code directly. But yeah, that's basically what I'm doing. um, so okay, you figured out in that way. And yeah, you're actually gonna do this for every red block. So for every comparison that you make, if you are putting a red block in there, you want to keep adding these numbers, right? So first you're going to get two, I don't know, maybe like you put a red block there, and then you put another red block there, and then you put yellow block, right? Two yellow blocks, and then you put like two red blocks, something like that. If that's the array that you'll get. So for this you have already made that addition, right? So you have incremented whatever variable you're talking about by 2. Next, maybe this was the one that went in there, that must have been the one, right? So for that again, now pointer 2 would be over there. So for that again, pointer 1 is the same, so you once again get 2. And then you move this pointer to somewhere where you don't have anything. So now this list is exhausted, you just keep putting this in. So once this list is exhausted, we don't have to do any addition to our variable, counter variable, because you know that these are just gonna lie to the right side of everything, right? And even if this list is exhausted, you have already counted all the inversions, so you don't have to do anything, because yeah, there are no more red blocks that are going to occur. So if you have now like added all of these numbers, what you basically get is the number of inversions between these two arrays. Add to that number of inversions while forming this array and while forming that array, and then you get the number of inversions in the original array you started with, right? And this is a recursive process, so like while forming this array you would be doing the same thing, and just write a recursive function. I don't know, whatever you're doing. Some people do it with while loops, I don't know what. Well, anyway, yeah, you get the answer with that. So basically just you know what, no, I'm not gonna give you the code answer for that. Okay, that's it. See you guys in the next video.